How many of you have wanted to be a rocket scientist or an astronaut? Well, you still have scope to be one, and just in case you're wondering what this lecture has to do with your future career, then watch the video till end. In this video, we are going to understand the forces in nature and the physics behind the fantasy space. So let's begin with a simple example. Consider you're moving a table from your living area to your study room. Can you name the forces acting on the table while it is stationary and while in motion? Think about it. When the table stands stationary on the floor, a force of gravitation, as per Newton's apple experiment, pulls it downwards towards the ground. When the table is in motion, it is acted upon by a drag force which has to be large enough to overcome the force of friction offered by the surface as opposed to the motion of the table. Do you see? There are so many forces involved in the simplest examples from our daily life. Now let's understand forces with another interesting example. Space exploration became possible only when rockets were introduced. But do you know how these space vehicles operate? When Chandrayaan-2 was launched recently, videos were telecasted across various media platforms, and all we saw was a rocket shooting up, leaving behind huge grey clouds of smog. All the rockets launched this way. I have this specific example because it was one of the successful missions in our generation, and the secret behind this success is force. You must be wondering why we have considered this particular example for understanding forces in nature. Well, my dear friends, that is because there are many forces acting on a rocket along with different parts of its journey to the space. This is the best way to give you an overall perspective about forces and how they tend to cause several processes. Simply speaking, forces acting on a rocket are popularly called the P4 forces, which means the 4 different forces acting on the rocket in different phases. Let's join a rocket on its journey to space and experience these forces. Imagine yourself sitting in a cockpit of Chandrayaan-2 about 30 minutes before it is set to launch. At this point, the rocket is indeed stationary and the engines are yet to be fired. This is the first stage, P1, where the rocket is standing upright due to the force of gravity, much like you and I can stand on the ground due to Earth's gravity. Now, a few seconds before the launch, you turn on Chandrayaan's emission control switch on the engines. Because of the emission of rocket fuel into the earth, an equal and opposite force as per Newton's third law of motion is generated that would thrust the rocket upwards. But the rocket still remains on the ground because it is still connected to the launch pad. Now the countdown begins. 10, 9, 8, 7, 6, and 1. At this liftoff, all the connections to the ground are removed, and finally the upthrust force overcomes the gravitational pull and the rocket starts its journey. Now airborne, as the fuel leaves the plane, it starts to become lighter in weight, which means lesser fuel is now needed to take it higher. Also, as soon as the fuel in the first chambers ends, you detach them, which makes the rocket even lighter. But wait, we are forgetting another force that comes into play as soon as you are airborne. Can you guess what I am talking about? Remember air resistance in Hyperloop technology, which was overcome by forming closed cylindrical structures in which the trains would move? Here we are talking about the same air resistance. This air resistance remains a part of the forces acting on the rocket throughout the period of flight. It is less in the beginning but increases to the maximum as the rocket accelerates and the air hitting on the rocket increases. From rest to the rocket gaining momentum, you have had enough challenges while sitting inside the cockpit. Eventually, the rocket reaches stage 4, which is the rocket is traveling upwards with a constant speed. This is the point where the upthrust, which is the upward force by the engines, the gravitation, which is the downward force by the earth, and air resistance, which again is a downward force but by the air, are all acting together on the rocket, forcing it to travel at a constant speed as they balance out each other by the same principle as discussed before. Meanwhile, you do this calculation to verify the constant speed of the rocket. Upthrust is equal to gravity plus the air resistance. With this upthrust, rocket keeps on moving upwards and finally escapes the atmosphere of the Earth, entering the space. Now imagine, something unfortunate happens and your engines suddenly stop mid-air. What do you think will happen? The upward thrust due to fuel release will be lost, and hence the only forces acting on the rocket will be the gravity and air resistance. Due to the existence of only downward forces, the rocket will quickly deaccelerate and eventually come back to Earth, as per Newton's first law of motion, which states that every object is in a state of uniform motion and will remain in that state of motion unless an external force is acting on it. That is why, to prevent something like this from happening, even commercial aircrafts undergo fuel checks and pilots sign off a detailed fuel requirement checklist before every single flight. The same is the case for rockets. Can you now think of how the rocket scientists calculate how much fuel would be required to launch the rocket into the space? They do it based on the mass of the rocket and the acceleration required to escape the force of Earth's gravity, as per Newton's second law of motion, which states that force F on an object is equal to the mass m of that object multiplied by the acceleration a of that object, meaning force is equal to mass into acceleration. Force is in the slightest of instances of our existence. We humans are able to stand, walk, run, and do everything while being on the ground due to gravitational forces. And our likes and dislikes connect us with people by the principle of attraction and repulsion. Isn't it amazing that not only physical existence but our psychology also works based upon forces in nature? Sitting in the cockpit and experiencing the actual journey to space is indeed a blessing, but definitely not practically possible for everyone. This is why alternate methods like flying rocket models or aircrafts cruising at heights are worth quoting as the best ways to understand these concepts while experiencing them practically. Flying model rockets is one of the methods which is a relatively inexpensive way of students to learn the basics of aerodynamic forces and the response of vehicles to external forces. Even an aircraft is subjected to forces of weight, thrust, drag, and lift, which are responsible for its passenger carrying and cruising abilities. You can consciously experience forces anywhere, even without the need of any costly models. From walking on the floor to writing on a paper, everything, whether in motion or whether it is stationary, is subject to some or the other kind of forces. I hope you enjoyed the video lecture and it helped you understand different kinds of forces in nature. We will see you in the next lecture. Till then, keep learning and keep growing.